So 7.2 is compound interest and half-life, okay? Compound interest, you guys, is one of those things that you will actually use in life. And I know people are always like, when am I going to use this? Oh, it's fine. Don't worry about it. Anyway, hey, come back. Compound interest gets used in your financial situations a lot if you care to be responsible in your financial situations. Well, maybe, but it's good to know. Okay, so here's the deal. With compound interest is basically saying how many times are they going to reevaluate how much money you have and then use that money to invest again, right? So compound interest means basically you could, well, look at your ABCD there. You could compound annually, which means once a year they calculate your interest and you get paid this amount of money, right? Or you could compound quarterly. Any guesses how many times in a year you would do quarterly? 4. There's 4 quarters in $1, right? Quarterly is 4 times a year, every 3 months, okay? What number would represent monthly? 12. And then daily? 365. Okay, now look at this formula. It should look very familiar to you because the formula we did yesterday looks an awful lot like this. The only difference is this N. Oh, that's not a highlighter. Here and there, okay? Otherwise, it's exactly the same formula. Now, what you do need to be careful with is that you plug it in as you see it. Don't do 1 plus R and then hit enter and then divide by N. That's not going to work. You want to just plug it in as you see it and it will be great. The N is going to represent the number of times something is compounded. So here's your first problem. Let's see if we can figure out how to set this up. It says you loan someone $400 at 6% interest per year. It's pretty good. You're going to make some money doing 6% interest. How much will they owe you after 1 year if it's compounded annually, quarterly, monthly, and daily? Now, keep in mind, you only loaned them $400, so it's not going to look like it jumps that much. But if you loan them $1,000, it's going to look pretty good. So first of all, you need to note this. The question is asking, how much will you have after 1 year? Your time in every one of these problems, this A, B, C, and D, is 1, okay? They're asking after 1 year, how much are you going to have? So let's try to set this up using that formula. It says A equals, what's the principal? Do you know? It's the 400. It's the original amount. It's the amount you started with, okay, is your principal. So 400 times 1. What's R right now? 0.06, right? 6% as a decimal. So 0.06. What's N for this annually? It's 1, right? 1 time a year. So you're going to do divided by 1 to the 1 times 1 power, okay? Now, technically, do you even have to use our formula from today? You could use the formula from yesterday and you plugged in exactly the same stuff, right? When it's annually like that, it really doesn't change anything. But for the sake of setting this up appropriately, we're going to do it this way. So try plugging that into your calculator right now, exactly how you see it. 400 parenthesis 1 plus 0.06 divided by 1 parenthesis to the 1 times 1 power. Plug it in. Plug it in. Well, until you get to the test and then you don't know how to plug it in. 424. Did everyone get 424? You should. Okay. So it's $424 that you would get at the end of the year if you loaned them $400 at the beginning. So you made $24 on that. Okay? You made some money just by giving someone else your money for a little while. Quarterly. Okay. So now this one, you're going to say A equals, and it's the same setup, 400 times 1 plus 0.06 divided by what? 4. Quarterly is 4. to the 4 times 1 power. Now, second enter. We'll put all that stuff that you already put in, and now you just have to replace your 2 1s with 2 4s. Do it that way, okay? Let me show you. I'm going to put it up here real fast, just in case anyone's struggling to see it. That's not what I wanted. Okay, so you're plugging this in, 400 parenthesis 1 plus 0.06 divided by 4 parenthesis to the 4 times 1.
Why do you have to put times 1?
You don't have to.
Sorry, just before.
But I'm just saying, yes, you can just put 4. 4 times 1 is 4, right? But I want you to see that if it's in 4 years, then you're going to do 4 times 4, right? So I'm just putting it in so that you see where that number is coming from. But yeah, you don't have to plug in the 1. Okay, so for this one, now you made $424.55. Okay, so not a lot more than you would have if you did it annually, but you're making more money. The more money you give them, the more money you're going to make off of them doing this, right? Okay, so monthly, do this. Second, enter. There's all your stuff, okay? You don't have to enter it all in again. Just go back, and now we're going to put what in for monthly?
12.
Okay, now let me show you something. If you just type in 12 right now, it messes all of this up. If you type a 1 and then go second insert, it'll give you that second space for your 12, okay? Second, and then the delete button inserts a space for you. Then it doesn't mess it up. Okay, now arrow over to the 4, and now 12 times 1, or you can just delete the 1 right now because 12 times 1 is 12, and hit enter, and you should be getting that number. Are you getting it? Okay.
Yes.
I have a loan right now for 3%. That's winning. Not that I'm giving. I am paying a loan that only has 3% interest. That's like a steal of a deal right now. My house. That's a big deal. Okay. Anyway. So for the monthly, right? We typed in a 12. It came out to $424.67. Okay. So daily, you're going to plug in 400, not 1,000, sorry, times 1 plus 0.06 over what? 365 to the 365 times 1. Plug that in. You will get $424.73. Okay. So this is a small example. So like I said, it's not growing by crazy amounts, but a lot of money is going to make a lot of difference depending on how much it's compounded. Okay, so that's if you compound annually, quarterly, monthly, daily. If you compound continuously, like all the time, compounding, there's this new little friend. His name is E. He's kind of like pi. He's a symbol that represents a number, right? So there's this formula. We call it PERT. You see why we call it PERT? It's the word PERT, right? P-E to the RT power. So when we say use PERT, it means we're using this formula. That only happens when compounding continuously. So if it says monthly or daily, you're going to use this one, right? All of these things, you use that top formula. If it's compounded continuously, you're going to use A equals PE to the RT power. Do you see an E on your calculator? Where is it? Oh, yes. Okay, so you can use that one. I have a better one for you. Above the comma?
That's 2 E's.
Where?
It's
Oh, right here, 2 capital E's. Okay, the one we're going to use, we want this one above the ln. E to the x power is going to come in very handy because it'll already give you the exponent there, and you're always going to have an exponent to your e. What? What is e? E is a number. It's a number. No, it's not. It's true. E is a number. Just like pi is a number, right? What? Yeah, that's different thing. That's a capital E, right? Okay, all this jumping around. Okay, so E, like it says here, right? Your P is your principal amount. That's your starting amount again. E is a constant. It is a number that never changes. It is the number approximately 2.7. That would be the rounded version. Don't plug in 2.7, okay? When you use the E letter in your calculator, then it doesn't round as broadly as if you just typed in 2.7, okay? So use the E function on your calculator. It'll be great, I promise. R is your annual interest rate, just like we've been doing as a decimal. T is your time, okay? So let's plug this in. It says, suppose you have $3,000 in an account that pays 2% interest compounded continuously. So right there, you should say, I'm doing this. How much will you have in 4 years? What is P? What's your principal? What's your starting amount? 3,000. So you're going to go 3,000 times E. What is R? 0.02. 2%, right? Divide by 100, so 0.02. And then times your T. What's T?
1.
Nope.
4.
4 years, right? Okay, so jump back to this calculator. Oh, yeah. I'm going to forget once today. Tell me if I'm not doing what's on the screen. All right, so you're going to plug in 3,000 and then hit second e to the x. So that's your ln button. Okay, and notice then it just does it for you. Now you can use the other one. You can use the one that's above the division symbol. You just have to use the caret then. It's really not that different. So now you're going to go 0.02 times 4 equals. Did you get that? You should be getting A equals 3,249. Where should I round right now? 2 decimal places. We're talking money. So 86 cents. Let me jump back to that for just a second, because then we're going to jump back again. I'm getting dizzy. Okay, so that works out to that. It's pretty straightforward, right? Plug it into the formula that's there. This next one, not quite as straightforward. So if you've been off in La La Land, you're going to want to come hang out with me for a little while. Here's what it says. How long will it take for $3,000 at 2% compounded continuously? What do you think when you hear compounded continuously? Pert. Okay. To double. How long will it take for $3,000 at 2% to double? Can anyone tell me what number goes there?
2. 6,000.
There we go. It started as 3,000. It became double that, so 6,000. So you're going to say 6,000 equals 3,000 times E to the 0.02 t. Okay, so now this one's a little different. And we don't know how to solve for an exponent. We've not done that at all. We'll do some of that later, but we're not there yet. So what we're going to do is we're going to graph it. And then it's going to find it very easily for you. You could also do the guess and check thing. If you want to just type in a number for t, plug in some numbers until you get to 6,000, that's okay. I would prefer you graph it because you'll get a more exact answer. Let me show you how. The first thing we want to do, just because it's going to make our window easier to find for our graph, okay, is we want to simplify this a little bit. So we're going to divide by 3,000 on both sides. And we get 2 equals e to the 0.02t. Okay, so those are the numbers that we're going to use right now as we graph this. So get your calculator out. If you don't already have it out, I'm going to share mine up here. And you've done this before. You guys know how to do this. It's very simple.
How do we get the t?
That's what we're going to do. We're going to figure out the t right now. Okay, so here's what you do. Click y equals. Oh, I already have them in. I'm going to take them out just so you see what I'm doing. So if you have stuff there, clear it out. Okay? We're going to put in the e to the 0.02t as our y1. So go second ln 0.02. And then your variable, it's going to be an x. It's representing a t for us. It's just a variable. It's a placeholder. Okay? So hit x, t, theta, n. Hit that button. Okay, so that's your y1. Your y2 is going to be the other side of our equation, that 2 that is there. Do you remember doing this when we had both of them and then we found the intersect of those 2 lines?
I do remember.
Does anyone remember how to find the intersect?
Yeah.
Yes.
Don't you just put like second trace?
Right, okay, so here's the deal. Second trace 5, okay, is how you'll find the intersect. But yours probably doesn't look like this right now. Did you graph it?
Yes.
Does it look like that? Probably.
Two lines.
Yeah, see, if you don't change your window, it won't show up. Now I think, try hitting enter, enter, enter right now, Sam. Did you get
Said no.
30? Oh, yeah. So you have to change your window. Are you done? Or you have a question? Done? Will you just stick it on my desk, please? Okay, so I had already changed my window in my first class, but you need to make it fit in the window that you have. So let's stop and think about this, okay? The T is time. So we don't know how many years it's going to take to double, but probably between like 0 and, I put 60. You could put 100. But it's not going to be negative years, right? So put a 0 in for your X minimum because you can't be a negative. I put 60. You could put 100. You could put 80. But make it big enough that we have time, okay? So put 0 in for X min. Put 60 in for X max. Then your Y value. Now think about this. Your second equation is Y equals 2. That's a horizontal line at 2, right? So really the only y value that you need to be able to see is 2 because eventually there's going to be an intersection there. So I just did a gap of from 0 to 5. Okay, so 0 for your y min, 5 for your y max, and now go second trace 5. We want the intersection. Okay, and remember these questions. Is this your first curve? Hit enter. Is it your second curve? Hit enter. Do you want me to guess where they meet? Hit enter. And they meet at 34.657, yada, yada, yada. So if you did the guess and check way, you'd probably tell me 35, because when you type in 35, you get 2.01, so it's close. If you do the graphing way, it's saying at 34.6 years-ish, 34.7 years is where we would double, where it would double. So I'm not super picky how you write that. If you just say t equals 34.6.7 years, that's fine. Or even approximately after 35 years, because that's where you'd actually be at the 2000, right? At the 35th year. That's fine. Questions on that? So it's graphing you've done before. Second, trace 5, but you just have to make sure you have a window that makes sense for what you're doing. Okay? Okay, last thing. HalfLife. You'll probably do this in science someday if you haven't already. Have you ever done HalfLife in science?
I know what HalfLife is.
It's good. What is it?
It's the time it takes for an object to decay by 1/2.
Yes. So half-life is a decay factor, right? To get to half of its value. Pull this back up for you. So there's an equation for half-life. Notice that's always going to be 1/2. It's half-life. So that is never going to change when we're doing half-life stuff. That's always going to be a half. A will still be your initial amount, but then your exponent is actually division. It's the time over the half-life. And this is a constant, and that will be given to you every time. Okay? So you just have to read the problem well and see what they're asking you for. Example number 4 here. The problem says barium-142 has a half-life of 10 minutes. So every 10 minutes, it gets cut in half. Okay? Write an equation for a 20 milligram sample. So what you're going to do is start by coming up with what is that equation. Y equals, what's your A right now? What? 20. Yeah, this number is just it's naming the element that we're talking about. So you're not going to use the 142 for anything, okay? Your initial amount was a 20 milligram sample. So you're going to put 20 there. And then like we said, it's always a half for your decay factor because it's a half-life. X is what we're going to be plugging in. So we're just going to call that X for now. What is your H? What's your half-life? 10. Every 10 minutes, it's getting cut in half. So that's going to go on bottom. Okay, so when they say write an equation, that's your equation. Okay, it says how much is left then after 1 minute? Okay, and we're working in minutes here. So all you're going to do is you're going to plug in a 1, y equals 20 times 1/2 to the 1 over 10. Now this time you have to plug in that 1, right? Because that's the fraction 1/10. It's not saying times 1. It does change what you're doing with it. So plug that into your calculator. You may do, if you like better, 0.5 instead of 1/2. It's the same thing, right? 1/2, 0.5, same thing. So 20 times 0.5 to the 1 divided by 10 power, enter. Okay, you get how much is left after 1 minute. That would be 18.7. What are we dealing with here? Milligrams. Okay. So then it says what percent is left. Do you know how to find a percent? That amount divided by the starting amount, right? So you just take that 18.7 and you divide by 20. So 18.7 divided by 20 is 0.935. What does that mean? 93.5%. Okay, so what percent after 1 minute? 93.5%. Okay. Then it says how much is left after 5 minutes. So if you go second enter, it'll bring up 2 things before, or you can just arrow up to that other equation again. You don't have to re-enter it all. You're just going to put in a 5. So it's going to be 20 times 0.5 to the 5 over 10. Okay, when you plug that in, you get 14.14 milligrams. Okay, do it again. How much is left after 10 minutes? Now stop and think about this for a minute. This is half-life, and this has a half-life of 10 minutes. So if it was 20, what's going to be left after 10 minutes? 10, half of it, right? That's your half-life. 10 minutes long is your half-life. So it's going to be 20 times 0.5 to the 10 over 10. So it's 20 times a half to the first power, right? So after 10 minutes, you'll have 10 milligrams. It cut it in half. So then it says how much is left after 1 hour. What do you have to plug in? 60. We're dealing with minutes here. So 20 times 0.5 to the 60 over 10. So really to the 6th power, if you will. And that comes out to 0.3125 milligrams. Not a lot left, okay? So this is an exponential decay situation. We started at 20 and it went like this, all right? Questions on that?
For C on the percent line,
Uh-huh.
did you get the divided by 20?
The original amount.
Oh,
You divide by whatever you started with.